Hello friends, in this video we shall discuss with respect to the previous year question paper of UGC NET Electronic Science paper which was conducted by NTA National Testing Agency on 23rd June 2026. The paper 2 consisted of 100 question which was asked for 200 marks. In this part 1 video, we shall discuss from question number 1 to question number 25. In the later part of the videos, we shall discuss from question number 26 to question number 100. If you are preparing for December 2026, you can take our YouTube membership. The links I am going to give in the description, or you can visit our channel page. In the first question, what they have given is, in an optical fiber, the refractive index of core, that is mu1, which is equals to 1.55, and the refractive index of cladding, that is mu2, which is equals to 1.5. Then what are the values of numerical aperture and acceptance angle? See, in textbooks, if you are referring through the core refractive index, they are going to represent by N1 or they are going to represent by NC, and the cladding refractive index they are going to represent by N2 or they are going to represent by NCL. Now look at the things. The numerical aperture that is given by NA, which is equals to under root of N1 square minus N2 square. I repeat, you are going to get N1 square minus N2 square, which is equals to, what is the value of N1, which is 1.55 the square minus 1.5 square. 1.5 square. On solving, see, what is 15 square? 225. What is 1.5 square, which is 2.25, right? So on solving, you are going to get the numerical aperture, which is equals to 0.3905. which can be taken as approximately equals to 0.394. Able to understand? And the numerical aperture is also defined as N1 times of root 2 delta. Now you can ask me, what is delta? Delta is referred as relative refractive index difference, and the delta is defined as N1 minus N2 whole divided by N1. So this is how you are going to find out the values of numerical aperture. So which two options you can eliminate means option 1 and option 2 you can eliminate so easily.
Then how to calculate acceptance angle?
The acceptance angle is given by theta naught, which is equals to sine inverse of numerical aperture. Sine inverse of numerical aperture. Now what is the sine inverse of 0.39? We don't know. So what we can do is we can take the help of a few things what we know. See, we know that sine 45, which is equals to 1 divided by root 2, nothing but 0.7, right? What is a sine 90, which is equals to 1? Now the value, that is a 0.721, if I am going with nothing but the angle variation is from 45 degree to 90 degree. Now the value is less than 0.7, nothing but the value of theta naught should be not 46, it should be less than 46, nothing but 23.2 degree. Which option is going to follow for question number 1 means option number 3 is going to follow. Let us move on to the second question. In the second question, what they have given is match the following. On the list 1, they have talked about dynamic hazards, setup time violation, semiconductor memories and demultiplexer. On the list 2, they have talked about synchronous sequential circuit, asynchronous sequential circuit, bistable circuit and combinational circuit. So based on this, if I am referring with this, demultiplexer is the combinational circuit. Correct. So for D, you should get a 3. Which option is going to follow? Option number 1 is going to follow, right? Now look at the things. In the case of dynamic hazards, it is referred to asynchronous sequential circuit. And in the case of setup time violation, it is synchronous sequential circuits. In the synchronous sequential circuits, you will be having two types of violations, right? You have to follow with the setup time as well as hold time. These two things are very, very important. And in the case of semiconductor memories you are going to realize with the help of registers. Registers, again, the basic blocks will be a flip-flop. Flip-flop is a bistable circuit element. flip-flop is a bistable circuit element. So for question number 2, which option is going to follow means option number 1 is going to follow. In question number 3, what they are given is the closed loop transfer function of a system is given by C of s divided by R of s, nothing but the transfer function, which is given by K divided by this term they have given. So we can compare this one with G of s divided by 1 plus G of s times of H of s. So this is the standard equation what we are referring with. Also we are going to assume the H of s value which is equals to 1 unity feedback. Now look at the things, the characteristic equation which is given by 1 plus G of s times of H of s, the value of H of s equals to 1, I'm going to equate it to 0. Now look at the things carefully. So what we will be getting is s into s square plus s plus 1 into s plus 4 plus k, which is equals to 0. On rearranging it and cross multiplying, what I will be getting is s power 4 plus 5s cube plus 5s square plus 4s plus k, which is equals to 0. I'm going to solve this one based on RH criteria, RH table. So here you will be having s power 4, s cube, s square, s power 1 and s power 0. Let us fill the table. So what you will be getting is the coefficient of s power 4 will be 1, and then you will be getting 5 over here 5 and 4, here you will be getting the value as k. Now what is this value? 5 5 is 25 minus 1 4 is 4. So that is a 21 whole divided by 5 you are going to get. What is this value? 5 times of k minus 1 times of 0 whole divided by 5, nothing but you are going to get k only. What is this value? 21 divided by 5 into 4 minus 5k whole divided by 21 divided by 5. And now what is this value? This value you are going to retain as k only. Now we know that for the system stability, this k value should be, or this term value should be greater than 0. So what I will be getting? 21 into 4, nothing but 84 divided by 5 minus 5k is greater than 0. Because this term, if I am sending on the right side, it will become 0 only. So what I will be getting? 84 minus 25k, which is greater than 0. Or what I will be getting? K less than 84 divided by 25. And with this one, what I'll be getting? K should be greater than 0. So what is the range of k you are going to get? Means 0 less than k less than 84 divided by 25. So the corresponding option that's going to follow is option B is correct.
What if k is greater than 84 by 25?
If the value of k is greater than 84 divided by 25, then the system will become unstable. So if the k value is in between, nothing but the gain value is in between 0 to 84 divided by 25, you can guarantee for the system stability. Once if the k value is less than 0 or it is tending to become greater than 84 divided by 25, then you are going to lose the system stability. Right? Let us move on to the fourth question. In the fourth question, what they are given is, which of the following parameters are associated with antenna? The gain of the antenna, okay, gain is associated. Modulation index is not referred with this antenna. And you will be having cross polarization. See, you will be having linear polarization, you will be having circular polarization, and you will be having elliptical polarization also. Balance modulator, again you are not going to deal with antenna. Directivity is the very important one. So which and all the parameters you will be referring means gain, cross polarization and directivity you will be referring with. So for the fourth question, option number 3 is going to follow. In the fifth question, what they are given is match the following list 1 and list 2. In the list 1, what they are given is a Schottky diode, tunnel diode, Zener diode and varactor diode. In the list 2, what and all the things they have specified means voltage regulator, high speed switch, voltage tuning of an LC resonator circuit and used in low voltage and high current rectifier circuit. Voltage regulator, which one you are going to use in voltage regulator? So you are going to make use of a Zener diode. You are going to make use of a Zener diode in the case of voltage regulator. In the case of voltage regulator, you are going to make use of a Zener diode, right? And the Schottky diode, which is used in, and the Schottky diode, where exactly you are going to use the Schottky diode? You are going to use in low voltage and high current rectifier circuit. Tunnel diode, very important, high speed switch. Where exactly you are going to make use of varactor diode means in the voltage tuning of an LC resonator circuit. See, when we were discussing with respect to the oscillator diagrams, see, you will be having various types of oscillator, like you will be having Hartley oscillator and Colpitt's oscillator, RC phase shift. At that time, I have explained the significance of varactor diode. Especially in the modulation also, you are going to make use of varactor diode, right? So it is used in voltage tuning of an LC resonator circuit. Which option is going to follow? Option number 4 is correct. Able to understand? In the 6th question, what they are given is, or what they are asking is, which of the following statements are correct? The superposition theorem is applicable to any network and systems. No, it is not applicable for all the networks and it is not applicable for all the systems. Say suppose you will be having 2 voltage sources, right? Consider V1 and V2. Followed by you will be having a simple diode, followed by a resistor. Now look at the things. If this battery voltage is 0.5 volts over here, if it is 0.3 volts over here, the circuit should conduct. But say suppose in the case of superposition theorem, we are going to consider one source at a time. So whenever we are dealing with one source at a time, this is a network, but then also superposition theorem is going to get failed, right? Whenever you are going to make use of 2 AC sources, it is going to get failed, right? So first option is an incorrect one. In the second option, what they have given is the reciprocal network comprises of linear, time invariant, bilateral, passive elements only. True. The Telegun's theorem is applicable to any lumped network having both linear and nonlinear elements. Correct. In the statement D, what they have given is the Thevenin's theorem is applicable to any linear network, time invariant or time varying one. Correct. Norton theorem is the dual of Thevenin's theorem. So, in which and all the cases Thevenin's theorem is applicable, their Norton theorem should be applicable. But what they are asking, Norton theorem is applicable to only time invariant linear network it seems. So, D statement is wrong. So, based on this, if I am solving, I will be getting option 3 is going to follow for question number 6.
Then what is the speciality of Telegun's theorem?
The speciality of Telegun's theorem is the Telegun's theorem can be applicable to calculate power and whatever is the nature of circuit. You can easily apply this Telegun's theorem. So this is the beauty of Telegun's theorem. See, the only one theorem that is applicable for all sorts of cases means that is Telegun's theorem, right? And usually in your previous year question papers, they have asked with for power calculations we are going to make use of which one? You are going to make use of Telegun's theorem. That's it. In question number 7, what they have given is the Laplace transform of the damped sinusoidal function, that is f of t, which is given by e power minus at sine of omega t. See, these things I have explained in my regular classes. Say suppose for the Laplace transform of sine of omega t or sine at, sine bt, whenever you are having sine, you should write omega divided by. Whenever you are going to define for cos, it is a s divided by. That's it. You will be getting the answer. So you will be having f of t, which is equals to e power minus at into sine of omega t. Sine of omega t means you should get omega over here. You should get omega over on the numerator. Correct? So omega divided by s square plus omega square you should get. But in the time domain, you will be having the multiplication factor of e power minus at. So whenever you are multiplying with e power minus at, what is the shift in the transfer function you will be having means omega divided by s plus a the whole square plus omega square, which is option A is going to follow for question number 7. Very, very important.
Can you explain damping factor?
Now look at the things. In the control systems you have studied with respect to the damping factor. Damping factor is denoted by zeta. What if zeta value is equals to 0? What is zeta value lies between 0 to 1? What is zeta value equals to 1? What is zeta value is greater than 1? And what if zeta is less than 0 or a negative value? Now what is the nature of curve you are going to get? In the case of zeta equals to 1, you will be getting a sustained oscillation. You will be getting a sustained oscillation. In the case of 0 less than zeta less than 1, nothing but zeta is going to decay. There will be an oscillation, but the oscillation is going to die. Right? The shock absorber what you are going to use in the vehicle, this is a perfect example of the zeta lying between 0 to 1. For zeta equals to 1, nothing but what? A critical system, oscillation tried to occur but will not occur. Zeta is greater than 1 means what? A rugged system or slow response system. No oscillation. Right? If a zeta value is less than 0, if a zeta value is less than 0, what is the nature of system you are going to get means unstable system. Oscillation keeps on increasing. Right? Very, very important. The nature of curve and the variations with respect to zeta, very, very important. In the 8th question what they are given is the impulse response h of n, which is equals to half power n into u of n plus 3. U of n plus 3 means which side shifting it is. Plus means what? It is a left side shifting. It is a left side shifting. It is a left side shifting. Right? Say suppose they have given h of n, which is half power n into u of n plus 3. Now say suppose they have not given u of n plus 3. Directly if they are given half power n, if they are given half power n, how you are going to define? For n equals to 0, anything raised to 0, you are going to get it as 1. Right? And next n equals to 1, what you will be getting? Half. For n equals to 2, what you are going to get? Half square, nothing but what? 1 by 4 you are going to get. Then at 3 you are going to get 1 by 8. At 4, how much you are going to get? 1 by 16. Like this you will be getting. So the curve is a decaying curve. Now this entire thing what you are going to do means you are going to shift by 3 bits. You are going to shift by 3 bits. Nothing but you are going to start this curve from minus 3. You are going to start this curve from minus 3. So at minus 3, what is the value you will be having? 1. At minus 2, what will be the value? It is half. It is half. At minus 1, what is the value you will be getting? 1 by 4. At 0, what is the value you will be getting? 1 by 8 and so on. Whether the curve is touching the imaginary axis, whether the signal is touching the imaginary axis, yes, the signal is touching the imaginary axis. So in an LTA system, nothing but in a Laplace transform, if the signal is touching this imaginary axis, then what is the nature of system? What is the nature of system you will be having? ROC on imaginary axis means it is a stable system. It is a stable system, very, very important. And it is a non-causal signal. It is a non-causal signal, right? Already I have explained what do you mean by causal signal, what do you mean by anti-causal signal, what do you mean by non-causal signal. If you have not gone through it, links I am going to give in the description, please go through once. And what is the linear graph and how non-linear signal you will be getting? What do you mean by time varying? What do you mean by time invariant? All those things I have explained. So based on this, if I am solving, I'll be getting option 3 for question number 8. Question number 8, option 3 is going to follow. In question number 9, what they are given is analog to digital converter having the conversion time which is independent of magnitude of analog input. Say suppose if I am considering a 3-bit one, if I am giving input as 001 and 111, so the conversion time should be independent of the inputs. In the flash A to D converter, the conversion time will be 1 clock cycle roughly. In the digital ramp, you will be having the conversion time 2 power n minus 1 times of t clock. In the successive approximation register type, the conversion time will be n times of t clock. Dual slope or integrating type, the conversion time will be 2 power n minus 1 times of 2 power n plus 1 minus 1 times of t clock. This is the slowest A to D converter you will be having. Very, very important.
Then what's the specialty of successive approximation and dual slope?
Now, this flash type A to D converter, you will be making use of 2 power n minus 1 times of comparators. 2 power n minus 1 comparator circuits you will be making use. So the circuit complexity will be very, 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 very high. So practically we are not going to prefer. But the most practical used A to D converter will be successive approximation A to D converter, right? The dual slope or integrating type, which is going to eliminate the hum effect, especially we are going to make use in digital multimeter. You are going to make use in digital multimeter. Very, very important, right? So for question number 9, the A to D converter which is having the conversion time which is independent of magnitude of analog input will be which one? It will be successive approximation register type as well as a flash A to D converter. So which one you will be getting? Option number 4 is going to follow for question number 9. Very, very important. In question number 10, what they are given is Maxwell's bridge is used for sharing bridge is used for Wien bridge, Kelvin's bridge. We know that the Maxwell's inductance capacitance bridge is used for the measurement of unknown inductance. What is the quality of the coil? Medium. Hayes bridge you will be having the quality as high. I told you the trick how to remember. Owens bridge quality will be low. Anderson bridge quality will be low. The sharing bridge, Shorty's bridge, D Shorty's bridge is used for the measurement of capacitance. Now, the Kelvin's bridge is used for the measurement of low values of resistance. See, resistor measurement you will be having low value, medium value and high value. For medium value you are going to make use of Wheatstone bridge. Kelvin's double bridge, all these things you are going to make use for the measurement of low values. All those things I have explained in the fast track sessions. And I have uploaded the fast track revision video also of electrical transducer. You can go through once. Links I am going to give in the description. You please go through once. Wien's bridge. See, 2025 June paper. The same thing they have asked. What is the frequency of Wien bridge oscillator? That's it. Right. So if you have gone through the previous year lectures, so it will be an easy one. The Wien's bridge is used for the measurement of unknown frequency, that is F is equals to 1 divided by 2 pi into under root of R1 R2 C1 C2. What we are going to assume? The resistance are same and the capacitance are same. R1 equals to R2 and C1 equals to C2, which is equals to C. What I will be going to get? 1 divided by 2 pi RC. This is the frequency of a Wien bridge oscillator. On solving, which option is going to follow means option number 3 is going to follow. In the 11th question, what they are given is the minimum number of 2:1 multiplexer. We know that the multiplexer is a combinational circuits which accepts not many inputs. Please be precise with the things. So the multiplexer is the one which will be expecting or which will accept 2 power n inputs and it will be having only one output. How many select lines you will be having? N select lines you will be having. Let us try to realize the 4:1 multiplexer. 4:1 multiplexer means what? You should have 4 inputs and you will be having only one output. Let us implement this 4:1 multiplexer with the help of 2:1 multiplexer. So this is I0, I1, I2, I3, right? And you will be having a single output. You will be having a single output. So I'm going to make use of 2 cross 1 multiplexer in order to realize a 4:1 multiplexer, right? So which one is frequently changing? LSB is frequently changing. Let me take this one as B and the input I am going to give it as A, right? What is the output? I am going to get it as Y. I0, I1, I2, I3. That's it. So in order to realize a 4:1 multiplexer, how many 2:1 multiplexer I have used? 3 I have used. 3 I have used. Similarly, in order to realize a 32:1 multiplexer, so 32 means what? 32 divided by 2, which is how much? 16. Again, 16 divided by 2. How many 2:1 you are in need? 8. Again, 8 divided by 2. How many in need? 4. Like this, if you are adding, you will be getting 31. So to realize a 32:1 multiplexer with the help of a 2 cross 1 multiplexer, how many numbers you are in need? Means 31 numbers of 2:1 multiplexer you are in need, right? So for the 11th question, option number 1 is going to follow. In my digital electronics lecture, these things are tackled, these kind of problems. Now look at the things. These type of questions, maximum persons they can solve. What if they are asking with to realize 35:1 multiplexer with the help of 2 cross 1? Many of them would have filtered out, right? In the 12th question, what they are given is match the following, list 1, list 2. This initial value theorem is nothing but f of 0 plus, which is nothing but limit as s tending to infinity. Final value theorem f of infinity means what? A limit as s tends to 0. So for C you should get 2 and for D you should get it as 1. Which option is going to follow? Option number 4 is going to follow. Now look at the things. What is Laplace transform of u of t? You will be getting it as 1. So what is u of t minus 4? Nothing but a shifting. Shifting in the case of time domain, which is nothing but what? Exponential in the case of frequency domain. So Laplace transform of u of t, I am going to get it as 1 by s, and Laplace transform of u of t minus 4 with minus sign, what I am going to get is minus 1 divided by s into e power minus 4s. That's it. And what is Laplace transform of t power 4 into e of minus at? You are going to get it as a n factorial, nothing but 4 factorial divided by s plus a the power of n plus 1. Nothing but what is 4 factorial? You are going to get 24 divided by s plus a whole power 4 plus 1. Nothing but 5. So for question number 12, option number 4 is going to follow. Very, very important. In question number 13, what they have given is a displacement transducer with a shaft stroke of 3 inch. So this entire thing is 3 inch is applied to the circuit of the figure that is shown below. The total resistance of the potentiometer is 5 kilo ohms. So this is 5 kilo ohms and the applied voltage is 5 volts. When the wiper is at 0.9 inches, so the total is 3 inch, but the wiper is at 0.9. What is the value of total output voltage? Now look at the things, simple thing. We can make use of potential divider. You can make use of the length and then you can solve, or you can make use of the resistance and you can solve. What is the total resistance? You will be having 5k. At what point it is touching? We don't know. Let us try to make use of length. What is the total inch? It is 3. At what point the shaft is making a stroke? 0.9. That's it. Into what is the total voltage? You will be having 5. That's it. That's it. So you are going to get it the output voltage as 1.5 volts. Or one more way is this potentiometer is a 5 kilo ohm. So 3 inches is corresponding to 5 kilo ohms. Then how much this 0.9 inch will be corresponding to? That's it. Like this also you can solve. So if you are solving, you will be getting the answer as 1.5 volts. Option 2 is going to follow. In 14th question, what they are given is which of the following is the most prevalent lithography technique for making mask? We know that we will be having two types of lithography, especially if you are reading to the Bucknell textbooks. One is electron beam lithography and the second one is photolithography, right? Apart from that, you will be having several variants. See, the advantage and disadvantage with respect to photo beam lithography and electron beam lithography is very, very important. In the case of photolithography, it is a parallel exposure. Parallel exposure. In the case of electron beam lithography, it is a series exposure. Here, the speed of operation will be faster. In the case of electron beam lithography, since it is a series exposure, it will be slower. In the case of photolithography, yield is, or the quality is less. You can talk about the quality is less. But in the case of electron beam lithography, quality is good. So, the most prevalent lithography technique will be electron beam lithography. For question number 14, option number 3 is going to follow. Very, very important. In the 15th question, straight away formula they are asking for a stable multivibrator. See, you will be having 3 variants of multivibrator. One will be monostable multivibrator, astable multivibrator, and bistable multivibrator. Bistable multivibrator you are going to use in flip-flops. Monostable multivibrator, drop a coin you will be getting the amounts of water, or drop a coin you will be getting a coffee, or nothing but vending machine. All those things it is going to make use of monostable multivibrator. In the case of astable multivibrator, there will be on off continuously. Nothing but what? Clock generation, spike generation, rectangular wave generation, all these things can be achieved. So the time period is given by 2 into RC into ln of 1 plus 2R1 divided by R2. Very, very important. Where exactly you are going to place the values of R1, R2, you please go through once. For question number 15, option number C is going to follow. In question number 16, what they are given is the minimum number of logic gates that is required for implementation with the help of using only NAND gates. And for the function f equals to ab plus cd. Now look at the things. A NAND gate output, what you will be having, say suppose if I am considering an input as x and y, what is the NAND gate output you are going to get? NAND gate output will be x into y the whole bar. X into y the whole bar. So complement you will be getting. Here no any complement is there. So what I will be writing is f equals to a into b plus cd. If I am taking double complement, logic will not change. True complement false, again false complement will be true. Same only, right? Adding double complement will not change. With the help of De Morgan's law, what is x plus y the whole bar? What is x plus y the whole bar? So which is equals to x bar into y bar. So this is based on De Morgan's law. So I'll be getting f equals to a into b the whole bar into c into d the whole bar. Again you will be having one complement. So a into b the whole bar, in order to realize I am going to make use of one NAND gate. C into d the whole bar I am going to make use with the help of second NAND gate. And the complement I am going to make use with the help of the third NAND gate. Third NAND gate. So how many NAND gates you are in need? Means you are in need of 3 NAND gates. So for question number 16, option 3 is going to follow.
But in the key answers, option 4 is correct.
In the key answer, option 4 is correct. Nothing but they are referring with 4 NAND gates are required. Look at the things. In the question, what they are asking is the minimum number of. See, in front of you, answer is there. I can able to realize the expression f equals to ab plus cd with the help of 3 NAND gates. So option number 3 is going to follow, and you can challenge this one, right? In question number 17, what they are given is the delayed step function is defined as. Now look at the things carefully. What is the step function? Step function is nothing but u of t, right? U of t. So t equals to 1 for u of t equals to 1 for t greater than 0, and u of t equals to 0 for t less than 0. At 0 the value will be half. This unit step function is also referred as a AV side function. Now look at the things. This coefficient may not be equals to 1. So I am going to take it as k. Now if I am shifting the curve towards the left, if I'm shifting the curve towards left, what I'll be getting is, with the help of k, what I'll be getting is k times of u of t minus, say suppose this value is minus 3, t minus of minus 3, I'm going to get it as t plus 3. This is what advancing. Delaying means what? This is how you're going to delay, right? So this is at 3. How we are going to define? Say suppose the gain is k, so it is k times of u of t minus 3. So you can take it as a, or you can write it as 3, 2, 1, whatever the example you want to take, you can take. Now for 17th question, option number C is going to follow. Nothing but, if you are shifting on the right, it is nothing but delaying. If you are shifting towards left, it is advancing. So for 17th question, option number C is going to follow. In the 18th question, what they are given is, on the list 1, they have talked about amplitude modulation, single sideband, suppressed carrier, narrow band FM and wide band FM. On the list 2, they have talked about number of sidebands are infinite, number of sidebands is 2, number of sidebands is 1, number of sidebands are 2 but opposite in phase. Now look at the things carefully. In the case of amplitude modulation, you will be having a carrier as well as you will be having 2 sidebands. In the case of single sideband suppressed carrier, you will be suppressing the carrier and one of the sideband, right? So in the case of AM, you will be having the number of sidebands are 2. And in the case of single sideband suppressed carrier, the number of sidebands will be equals to 1. So for A, you should have 2. And for B, you should have 3. So based on this, option number 2 is going to follow. And in the case of narrowband FM, the number of sidebands are 2 but opposite in phase. And in the case of wideband FM, the number of sidebands are infinite. As the name indicates, wideband FM, wide, nothing but what? The number of sidebands are infinite in number. So based on this, if I am solving for question number 18, option number 2 is going to follow.
Can you explain the types of amplitude modulation?
In the case of amplitude modulation, the amplitude modulation is further classified as simple AM. It is classified as simple AM. In this, you will be having the carrier signal as well as 2 sidebands. See, if I am talking about the efficiency will be 50% provided the carrier you are going to make use as a square one. But practically, sinusoidal signals will be used in the carrier, right? So the efficiency will be at max 33.33%. But if they are asking what is the efficiency of a simple AM, you should tell it as 50, because if you are taking square wave, then you will be getting 50. How? Efficiency is given by mu square divided by 1 plus mu square. In the case of sinusoidal, it is given by mu square divided by 2 plus mu square. Like this you are going to take and then you are going to solve. In the case of DSBSC, what exactly you are going to do means you are going to suppress one of the carrier. You will be left with what? 2 sidebands. You will be left with what? 2 sidebands you will be having. Why 2 sidebands you are going to use? Anyway, both of them carry the same information. So what exactly you are going to make use means in a single sideband suppressed carrier, you are going to suppress one of the sideband. So you will be having only one sideband. But designing a filter is very important and it is a critical task. So that sharpness you can't achieve. So only you are going to make use of vestigial sideband, nothing but one sideband fully you are going to take, another sideband a part you are going to take, and then you are going to solve, right? So this vestigial sideband where you are going to practically use means in the case of television broadcasting, you are going to make use of vestigial sideband. So these are the types of AM you will be having, right? So you will be having simple AM, you will be having double sideband suppressed carrier, single sideband suppressed carrier, vestigial sideband. So 18th question, option number 2 is going to follow. In the 19th question, what they are given is, in the given circuit of phase shift oscillator, the frequency of oscillation and the relation between RF and R1 is given by. Now look at the things carefully. The frequency is given by 0.065 divided by RC, provided R1 equals to R2 equals to R3, which is equals to R. and C1 equals to C2 equals to C3 equals to C. And 1 divided by 2 pi root 6 is nothing but 0.065. Very important. 0.065, very important. So this conversion you should know. And one more thing, you please think about it. This RF by R1 is nothing but your gain AV, which is equals to 29. Now what is the value of beta? This implies what is the value of beta? Beta equals to 1 divided by 29. And look at the things carefully. For the sustained oscillation, the value of A beta should be equals to 1. 29 into 1 divided by 29 is 1. But what is the practical value of A beta? A beta should be at least greater than 1. The practical value is 1.02. 1.02. Right? So in the case of RC phase shift oscillator, the frequency is nothing but what is the value? 0.065 divided by RC. Very important. And the value of open loop gain AV, which is nothing but 29, and the feedback factor beta equals to 1 divided by 29. The op amp you are going to use is a inverting configuration, which is having a phase shift of 180 degree. The this tank circuit you are going to use, sorry, this is not referred as tank circuit. This is referred as a feedback network. With a feedback network you are going to achieve a further phase shift of 180 degree. So the total phase shift will be equals to 360 degree. For question number 19, option number 2 is going to follow. Very important. In question number 20, what they are given is the address they are asking in the case of 8051 microcontroller. We know that for the accumulator you are going to make use of what is the address? 0E0H, right? And the stack pointer you are going to make use, or you have to just mug up the value, that's it. It is 81H. So these two, if you are knowing, means you can able to solve the things easily. So for this stack pointer, it is 81H, and for accumulator it is 0E0H, right? So based on this, if you are solving, which option is going to follow, means option 3 is going to follow for question number 20. Very important. In question number 21, what they are given is, on the list 1 they have given common emitter configuration, common collector configuration, common base configuration, and common emitter amplifier with emitter resistance. With emitter resistance, what exactly you are going to achieve means the stabilization will be improved. Input impedance increases because the RE resistor will be acting like a feedback. What you are losing? Gain you will be losing, that's it. Now look at the things carefully. When I was explaining with respect to these stuffs, common emitter, common collector, common base, you take any things of your choice. Input impedance, output impedance, and the current value, the gain value of the voltage gain, current gain, all these things if you are considering, emitter configuration, nothing but common emitter will be in between common base and common collector configuration. Now look at the things carefully. In the case of common collector configuration, the voltage gain is less than unity. So for B, what you will be getting is 1, not an issue. In the case of common base amplifier, you will be having a low input resistance. For C, you should get a 3. In the case of common emitter configuration, you will be having a high input resistance. Okay, you can consider. Now, in the case of common emitter amplifier with emitter resistance, it is a non-linear distortion, correct? Strictly speaking, the options are again still it is in mismatch only. Voltage gain less than unity, I have to match for this, so it will be common collector configuration. But high input resistance if I am taking, it will be common collector configuration only. Common collector configuration will be having high input resistance when compared to common emitter configuration. Right? In the mock test also I have asked, they have asked the value as 550 kilo ohm and 500 kilo ohm. So what is the common emitter amplifier input resistance means 50 kilo ohms, right? So the common emitter amplifier will be having a moderate input resistance and moderate output resistance. and the phase shift is 180 degree. In the case of common collector configuration, why exactly you're going to make use of common collector configuration means, though it is having voltage gain as less than unity or unity follower, but its input impedance is high and output impedance is low. And common base amplifier will be having a low input impedance and high output impedance, right? Comment your answers in the comment section where exactly you're going to make use of common base amplifier, right? So for 21st question, which option is going to follow means option number 2 is going to follow. Strictly speaking, the options are not proper. There is a mismatch with common emitter. In 22nd question, what they are given is, in 8051 microcontroller, what is the content of accumulator register A and carry flag status after execution of the following instruction? What is the first thing they are going to execute means clear C, nothing but the carry flag contents will be equals to 0, and the value of A, nothing but accumulator, is loaded with 3FH, and the value of register R3 is been loaded with the 23H. What exactly they are going to do means subtraction of R3 with or from A with borrow, nothing but they are going to perform A minus R3 minus carry flag contents. What is the carry flag contents? 0. What is the value of R3? It is 23, and accumulator value is 3FH. What is F minus 3? You will be getting EDC, nothing but you are going to get C over here, and 3 minus 2 is 1. In order to perform this subtraction, have you made use of borrow? No, you have not made use, right? So the accumulator value will be what? 1C. Accumulator value will be what? 1C. Very, very important. So which options you can eliminate? Option 1 and option 3 you can easily eliminate. So the carry flag contents will be 0. In order to perform the subtraction, you have not made use of any borrows, right? So accumulator value will be 1C and the carry flag value will be, or the carry flag status will be 0. So the corresponding option that is going to follow for question number 22 is option number 4 is correct. In question number 23, what they are given is, which of the following Boolean equations can be implemented using a 2:1 multiplexer? Which one of the following can be used with the help of 2:1 multiplexer? Now look at the things carefully. What is a multiplexer? It's a combinational circuit. And is it a universal gate? Yes, multiplexer is an universal gate. In the detailed videos of digital electronics, I have explained with respect to universal gate. Not only NAND and NOR gates are universal gates, even multiplexer is an universal gate, AS gate is an universal gate. So this Boolean expression F equals to A XOR B, you can easily realize with the help of multiplexer, right? Yes, you can realize. And then F equals to AB bar plus CB, you can able to realize, not a problem. F equals to A plus B the whole bar, NOR gate, you can able to realize with the help of universal gate. F equals to A into B the bar, A into B bar, you can able to realize, right? So A, B, C, D you can able to realize. Very, very important.
Statement E refers to sequential design, right?
Yes, statement D refers to sequential design. In this, you will be having the next state value is dependent on the present state as well as enable. Present state as well as enable. See, enable you can consider as select lines also, not an issue. But you will be having the present state and next state, which is again a function of clock, which is again a function of clock. So if I am opting for the answer, I'll be opting with A, B, C, D. But in the key answer, what they have specified is A, B, C, D, nothing but the statement E also can be realized with the help of 2:1 multiplexer. Comment your answers in the comment section whether it is correct or wrong. In the 24th question, see, we are having two types of oxidation. One is wet oxidation and the second one is dry oxidation. Already I have explained. Wet oxidation is what? Faster. Dry oxidation is what? Slower. Which one is going to make use of water vapor? Which one is not going to make use of water vapor? Please comment. And in the case of quality, in the case of wet oxidation, the quality will be less. In the case of dry oxidation, quality will be high. You will be having thin oxide and you will be having thick oxide. The wet oxidation, you are going to realize, or for thick oxidation, you are going to make use of wet oxidation technique. And for thin oxide implantation, we are going to make use of dry oxidation technique. Very, very important. Based on this, you try to attempt. In the statement A, what they are given is dry oxidation is faster than wet oxidation. Is it? No. Wet oxidation is faster than dry oxidation. True. Oxide deposition is used to form gate oxide of MOSFET. Wrong. Silicon oxynitride, nothing but SiON, has higher dielectric strength when compared to silicon dioxide. True. The thermal oxidation at high temperature increases fixed ion charges. Wrong. So which statement is a confusing one? Means E statement is a confusing one. But B and D is anyway it is following. B and D is anyway it is following. So E statement you can easily skip or easily you can neglect. So for this question number 24, which option is going to follow? Means option number 1 is correct. In question number 25, what they have given? Choose the correct option in the context of resources that is available in 8051 microcontroller chip. Now look at the things carefully. In the case of RAM, it is of 128 byte RAM. So random access memory, what is the size? Means it is 128 bytes. And what is the size of ROM? Means it is 4 KB. The internal ROM is 4 KB. You can add up to 60 KB. Totally it can be extended up to 64 KB. Not an issue. You will be having how many timer? Means you will be having 2 timers. Timer 0 and timer 1. So you will be having 2. So 128 bytes of RAM and you will be having 2 timers and 4K of ROM. Which option is going to follow? Option number 3 is going to follow. Very, very important.
Total number of interrupts is 5, right? Can we expect grace marks?
No, you can't expect the grace marks even though the number of interrupts are wrong. Now look at the things. In the case of 8051, you will be having 5 interrupts. In the case of 8051, you will be having 5 numbers. Which and all you will be having? Means let us discuss one by one. The first or the highest interrupt that is available is external interrupt 0. External interrupt 0, or it is also referred as INT 0. The second one will be timer overflow or timer 0 overflow. You can also write it as a TF0. Next one will be external interrupt 1 or INT1. The fourth one will be timer 1 overflow. Timer 1 overflow or TF1. Fifth one will be serial interrupt. Serial port interrupt. In the case of serial port interrupt, you will be having receiver interrupt as well as a transmitter interrupt. Maybe because of this receive and transmit, they have taken it as 6. But strictly speaking, you will be having 5. What is the address? Very, very important. So this one will be 0003H. Next one will be for TF0, it is 000BH. Next one will be 13H. Next one will be 001BH. And for serial port, it is 0023H. Very, very important. Maybe this NTA fellows, they have assumed or they have considered serial port interrupt, receiver and transmitter will be there, no? So they would have considered this one as 2 interrupts. So only they would have opted, or they would have given an option as a 6 interrupts, right? So for question number 25, option number 3 is going to follow. Very, very important. So friends, in this part 1 of the video, we have covered from question number 1 to question number 25. In the next part of the video, we shall discuss from question number 26 to question number 50. If you have understood with the solution lecture, please give it a big thumbs up.
Will they like this video?
Yes, they will like the video. For my small effort, I am expecting a big thumbs up from them. So friends, if you have understood with the solution lecture, please give it a big thumbs up. Also share this video with your friends, and don't forget to subscribe to my channel Craving Gyan. All the best for exams. If you are preparing for December 2026 exam, don't forget to join our YouTube membership today. All the best for exams and all the best for your results. Thank you.